So you made the big move to drip irrigation. Smart move. It's now time to schedule your irrigation. Looks like a big deal? Don't worry, it's easy. Actually, irrigation is all about balancing water availability in the soil. Soil has a capacity to hold water, and plants consume that water. Our job is to give the soil back the water that the plants have consumed. This way your plant never dries out and won't suffer from stress. Okay, so that's clear. We need to apply the amount of water the crop is consuming in order to stay balanced. But how do we calculate field's water consumption? The water consumption of a field is called evapotranspiration, or ET for short. ET is the sum of water that the plants consume by transpiration along with evaporation from the soil. ET is calculated based on meteorological data considering temperature, humidity, wind speed, and radiation. But every plant will transpire a different amount of water, no? Yes, the water consumption of a specific crop in a specific field is called ETC. To find the ETC, we follow a simple equation. Don't worry, it's really easy. Let's take it step by step. The measured value of ET is called ETO. This represents the evapotranspiration from a standardized vegetated surface of grass. Where do you get the ETO values from? Either from a weather station located in your farm or from the Nטפים ETO application. So how do you move from a reference grass to your crop in its specific growth stage? Each crop in every growth stage has a factor called KC. The crop factor represents the properties of the crop. So we simply multiply the ETO by the crop factor. How do you find out a crop's KC? Simple. Just do a quick internet search, consult the crop literature, or ask an irrigation specialist. So in order to work out the actual water consumption of your crop in a specific field at a specific growth stage, that is, to get the ETC, we simply multiply the ETO by the crop factor. Here's an example. Let's say you have a cotton field. According to the local weather station, yesterday's ETO was 6.5 millimeters. The cotton in the field is at growth stage, vegetative growth. And according to the KC values, your KC is 0.2. Now we do the math. An ETO of 6.5 millimeters multiplied by a factor of 0.2 equals 1.3 millimeters. And that's your cotton field's actual water consumption for yesterday. This means your field needs 1.3 millimeters or 13 cubic meters per hectare for its optimal water balance. ETC is a dynamic value because the ETO changes daily according to the weather and the KC changes periodically according to the crop growth stage. Now what happens if you're not irrigating daily? In this case, you need to sum the ETC of the days since your last irrigation event. The sum is the amount you'll need to irrigate. Now you know more about precision irrigation. It's time to irrigate.